Hi, this is Aldin Schliewenz presenting solutions for problems 4 and 5 in the assessment quiz on three-dimensional vectors and force systems. So for problem number 4, I determined the forces and wrote them in component forms. F1 is cosine of alpha, cosine of beta, and cosine of gamma in pounds. F2 is 200 pointing in the negative y direction, which is 0, negative 200, and 0 in pounds. F3 is in the xy plane, which is 400 minus sine of 30, 400 cosine of 30, and 0 in pounds. I found the resultant force by adding F1, F2, and F3, which is equal to 0, 0, negative 350, which those are equal to F1 cosine of alpha minus 400 sine of 30, F1 cosine of beta minus 200 plus 400 cosine of 30, and F1 cosine of gamma in pounds. I wrote equations to help solve the terms with F1. 0 is equal to F1 cosine of alpha minus 400 sine of 30. It is also equal to F1 cosine of beta minus 200 plus 400 cosine of 30 minus 350, which is equal to F1 cosine of gamma. F1 cosine of alpha is equal to 400 sine of 30. F1 cosine of beta is equal to 200 minus 400 cosine of 30. And F1 gamma is equal to negative 350. To calculate the magnitude, I did the following. Magnitude of F1 is equal to the square root of 400 sine of 30 squared plus 200 minus 400 cosine of 30 squared plus negative 350 squared, which is equal to 429 pounds. I used the previous equations I wrote and plugged in the values to get the final answers. Cosine of alpha is equal to 400 sine of 30 over F1, which is equal to 62.2 degrees. Cosine of beta is equal to 200 minus 400 cosine of 30 over F1, which is equal to 110. Cosine of gamma is equal to negative 350 over F1, which is equal to 145. For problem 5, I wrote position vectors to arrive at points A and B. RA is equal to 0, 3, 0 feet. RB is equal to 2, and negative 2 feet. RO is equal to 0, 0, and 0. RAO is equal to RO minus RA, which is 0, 0, 0, minus 0, 3, 0, which is equal to 0, negative 3, 0 feet. RAB is equal to RB minus RA, which is equal to 2, 2, and negative 2 minus 0, 3, 0, which is equal to 2, negative 1, negative 2. Then I use that information to find the magnitudes, which is R of AO is equal to the square root of 0 squared plus negative 3 squared plus 0 squared, which is equal to 3t. RAB is equal to the square root of 2 squared plus negative 1 squared plus negative 2 squared, which is equal to 3 feet. I then use the unit vector for A back to the origin, which is 0, negative 1, 0, which is RB minus RA over RB minus RA, which is equal to 2, negative 1, negative 2 over the square root of 2 squared plus negative 1 squared plus negative 2 squared, which is equal to 2 over 3, negative 1 over 3, and negative 2 over 3. And then use the dot product notation to solve, which is 2 over 3, negative 1 over 3, negative 2 over 3 times 0, negative 1, 0, which is 2 over 3 times 0 plus negative 1 over 3 times negative 1 plus negative 2 over 3 times 0, which is equal to negative 1 over 3. Theta is equal to cosine of negative 1 times times 1 over 3, which is equal to 70.5. To sum things up, I used x, y, and z vector components to solve complex forces. It made it much easier. I also used simple math to turn flat 2D angles into exact 3D lines and lengths. I look forward to applying these concepts when working with truss joints and cable bridge connections in civil engineering. Thank you.